Hi ladies and gentlemen, this is Ms. Skokin, and we're going to start the next lesson right away. It is recommended that teenagers get 8 hours of sleep per night. Ms. Skokin believes that her AP Stat students are getting less than the recommended 8 hours of sleep per night. To help her test this belief, we take a random sample of 10 students and record the number of hours of sleep for each. Do these data provide convincing evidence that the AP Stat students get less than 8 hours of sleep per night using an alpha of 0.05? Let's take a look at our data. Grab your calculator and put these numbers into your list so that you can calculate the sample mean and standard deviation for number 1. So our sample mean is X bar, and we get 7.2 hours. Our sample standard deviation is 2.044. Remember, we always use 3 decimal places. And of course, our units is going to be the same as the mean hours. The next thing that we're going to do is we're going to put together our hypotheses for our significance test. And our null hypothesis, you might have already guessed, is mu is equal to 8. Our alternative hypothesis is mu is less than 8, and we have to explain what mu is. Mu is representing the true mean hours of sleep for AP Statistics students at our school. Okay, at this point we're ready to check conditions. The first condition is the random condition, and we know that we took a random sample of 10 students. The next condition for us to check is the 10% condition. We definitely did not meet this condition because our population is not more than 10 times our sample size, because we don't have at least 100 AP Stats students. So we recognize that this condition, the 10% condition, is not met. But remember, the reason that we check condition is for independence when we're sampling without replacement. And although we sampled without replacement, we can reasonably assume that every individual's number of hours of sleep is independent from every other individual's numbers of hours of sleep. The last condition that we're going to check is the normal condition. And unfortunately, the sample size is too small for the central limit theorem to apply, so that means that we are going to have to graph our sample and check to see if we see any strong skew or outliers. Let's start with the modified box plot because that graph can tell us if we have any outliers. So remind yourself how to do it in the calculator. You're going to go to second, y equals, and select the modified box plot, which is the one with the little dots. And then you're going to select the appropriate list and zoom 9. When you draw your graph, you've got to show the scale. And remember, we use the 5-number summary to create the box plot. So we find that our minimum value is 4, our maximum value is 10, and we have our median at 7, Q1 is at 6, and Q3 is at 9. We join up the interquartile range and then draw the 2 tail ends. We can see from our calculator we don't have any outliers. We have a little bit of skew, but it's not a strong skew. So the next thing that we're going to need to do is take a look at the histogram. So go back to the calculator. This time, when you go to the statistical plots, you're going to select the histogram. And again, zoom 9, but then go back and change your window to something that makes sense. And also got to scale the histogram. So from neither our box plot nor our histogram do we see anything that we need to be concerned about. We can say we have met roughly all 3 conditions and we're ready to move on. Let's take a look at number 4. Give the formulas for the mean and standard deviation of the sampling distribution of X bar and calculate the values. Just a reminder, mu sub X bar, the mean of the sampling distribution of the sample means, is always equal to the population mean, so that's going to be the one that we use from our hypothesis value. So that's going to be 8, and our standard deviation of the sampling distribution of sample means is going to be the sample standard, or the population standard deviation divided by the square root of the sample size. So since we don't have the population standard deviation, we're going to use the approximate value given to us by the standard deviation of the sample, and we're going to divide that by the square root of n. Remember, we call that the sample or the standard error. Okay, so we plug in our values, and we have 2.044 divided by the square root of 10, giving us 0.646. And both of these units are hours. Okay, draw a picture and then calculate the test statistic, and that means it's time to sketch and shade. So we have our approximately normal curve, and we know that that is going to be defined by the mean and the standard deviation from the previous question. And we'll go ahead and graph where our sample value is, and that was 7.2 was the mean. Okay, so we drew a picture. Now we need to calculate the test statistic. And we remember that z is going to be equal to x bar minus mu over s sub x divided by the square root of n. Okay, let's move forward. It says, remember, since we're working with means, the test statistic is a t-value. Use table B to find the p-value. Uh-oh, we can't use the normal curve. We've got to use the t-curve. And if you remember, the t-curve is based on a number of degrees of freedom. Since degrees of freedom is equal to n minus 1, and in our case we have a sample size of 10, our degrees of freedom is going to be equal to 9. And our test statistic name is not going to be z, it's going to be t. So let's plug in. We know our sample mean was 7.2, our null hypothesis parameter value is 8, and the standard deviation or standard error that we found in number 4 is 0.646. So that means our test statistic t is negative 1.25. And now we want to find in table B that, or we could do it in the calculator. So we'll look at each one of those in turn. As we look at table B, we go to the degrees of freedom equals 9 line, and we scan across until we see the value of our test statistic. Now, just a reminder that even though we got a negative test statistic because it's on the left-hand side, we know that table B has symmetry, so we're finding positive values only, and we are just going to use those values but to the negative side to indicate that left-hand or less than probability. Anyhow, we find on the degrees of freedom equals 9 line, we find between 1.1 and 1.383 our value of 1.25 can be found. And that means that the p-value is going to be between the two values 0.10 and 0.15, which if you scan upward from the two values that are surrounding our test statistic value, you'll see the tail probability numbers. The other way that we can do this, of course, is with TCDF. And for TCDF in the calculator, we go to second vars, and then we use the lower bound of negative some big number, the upper bound of our test statistic value, and then the degrees of freedom, which is 9. That ends up giving us a p-value of 0.121, which of course is between the two values that we found on the table. And then we're ready to draw our conclusion. So what conclusion can we make? We're going to recognize that the p-value, which is equal to 0.121, is greater than our alpha of 0.05. So because it's a greater than, we're going to fail to reject the null hypothesis. And as it turns out, we do not have convincing evidence that the AP Statistics students sleep less than 8 hours. So once we've got this done, of course, we're going to go on to the next page and we are going to fill in our box of important information, and then we'll have our check for understanding. To start with, let's take a look at the conditions that we're checking. The first one is random, and that randomness can occur either through random selection, as in a survey, or random assignment, like when we have an experiment conducted. The next condition is the 10% rule, and remember that this is all about independence. And this is met when the sample size is less than 1/10 of the population size. If we don't meet the 10% condition, remember to check and see if each individual value that we get is independent of every other. And then it can meet. The other, of course, opportunity is if we're sampling without replacement, which doesn't happen too often in the real world. The last one is going to be the normal condition. And the normal condition, we have three different possible ways that we can meet it. The first one is that the parent population is normal. And then we can say that the sampling distribution is also approximately normal. The next one is if the sample size is at least 30, because then the central limit theorem applies. And last of all, if neither one of those two are met, what we can always do is graph the sample and make sure that there's no strong skew or outliers. So the next thing that we're going to take a look at is the test statistic. And the test statistic is going to be T. The formula for our test statistic is going to be the sample value minus the null hypothesis value over the standard error. And remember that we're still going to sketch and shade, so we're going to have a bell-shaped curve, but the T curve is based on the degrees of freedom. So that's something that we're going to have to be aware of. All right, last of all, let's talk about finding the p-value. And the p-value, we can either use table B with the degrees of freedom and the tail probability, or we can use TCDF. If you need practice, please practice both of these methods so that you can easily and quickly find the p-value, which will allow you to make a conclusion about the hypothesis test. Okay, now it's time for the check your understanding. What I'd like for you to do is go ahead and read through the question, turn the video off. We're not in that order. Turn the video off, read through the question, work on it, and then turn the video back on when you're ready to check your answer. So I'll see you back in a minute once you've had a chance to work this through. Here is the full worked out solution for this question. Just a reminder, when you're going through the question to begin with, circle, underline, make notes of the important information given to you that you know that you're going to be using for the four-step process. Then when you use the four-step process, you need to make sure to include the specific different pieces of information that are required for each of the sections: state, plan, do, and conclude. It is well worth it practicing these questions from the textbook to make sure that you can comfortably access all the important information and place it in the right sections so that You can include all the justification needed for your conclusion, which comes at the end of this question. That's it for now, and I will see you back in the next lesson.